Welcome back to the Mathematics and Smile Academy. We are still with Nanda VC, the director. So we are continuing with the discussion on the application of differential equations to finance and economics problems. And then the next problem. So I've been told that in a national economy, I, Y, and C denote in trillions of dollars the level of investment, income, and consumption respectively at time t. And then these quantities are given by these equations. C is I minus the derivative of Y. I is the same as a quarter into 1 plus 3Y minus 4 times the second derivative of Y. Then C is a half at t equals to 0, and I is 7/2 at t equals to 0. Then we are told that the Y function is related to C and I by Y equals to C plus I. So the first part of the problem is to show that Y function satisfies the differential equation second derivative of Y plus first derivative of Y plus a quarter Y equals to 5/4. And then once we have ascertained that Y satisfies that equation, we need to find the solution for Y. After getting the solution for Y, we need to deduce the expression for C and I, then describe this behavior of these solutions as t increases. So we'll solve this problem, and feel free to make any inquiries on further applications of the differential equations as far as economics and finance is concerned through my personal email, vcnando@unbi. Or you may WhatsApp through so you'll then be able now to discuss more the problems as far as the applications of differential equations to finance and economics are concerned. So let's swing into action to solve the problem at hand. So the first part is very easy. It's just to show that when we put C and I with the given functions for C and I into the equation Y equals to C plus I, then we get this given differential equation. So what we are going to do is to take the C function, add to I function, simplify and see how we can get this structure. So solution. We know that we have been told that the investment, the income is given by Y equals to I plus C, or C plus I. So Y is going to be C. I function is given by 1/4 into 1 plus 3Y of t minus 4Y double prime of t. Then I add to C function, which is given by 1 minus first derivative of Y. So if I open the brackets, I get Y. So Y, I mean Y of t. So I have a quarter plus 3/4Y minus 4 times a quarter is 1. Then plus 1 minus Y prime. So that I'll have collected terms y equals to or I can bring all the right-hand side terms to the left-hand side. So negative y double prime will be positive y prime, y double prime. So this will be plus, and then this will be plus, and then plus this y, then minus 3/4y, then minus a quarter, minus 1 equals to 0. So I have y double prime, this is prime, plus y prime. 1 minus a quarter is 1 minus 3/4 is a quarter. Minus 1/4 minus 1 is minus 5/4 equals to 0, which on rearranging, we have second derivative of y plus first derivative of y plus a quarter of y is equals to 5/4. And this is what we are supposed to show in the first case. So first part of the problem is correctly done or correctly proved. So then now, second part was to solve the equation involving y. So then now, to solve this, so remember this is a second order non-homogeneous linear differential equation. Second order linear differential equation. Linear non-homogeneous equation. Differential equation. So to solve non-homogeneous differential equation first, we know that the solution will be given by YH plus YP, where YH means homogeneous solution, YP means particular solution. So to get homogeneous solution, we let the right-hand side of the equation to be 0. So we have y double prime plus y prime plus a quarter y equals to 0. This is a homogeneous equation, which will help us to get the homogeneous solution. Now we let y equals to e raised power r t be the solution, which means y prime will be r e raised power rt, and y double prime will be r squared e raised power rt. Then substituting this into the given equation, you'll have r squared e raised power rt plus r e raised power rt plus a quarter e raised power rt equals to 0. Then we have e raised power rt into r squared plus r plus a quarter equals to 0. Since the exponential can never be 0, then this means r squared plus r plus a quarter is what is 0. And this is what is called the characteristic or auxiliary equation. Then this is a quadratic, so r will be given by minus b, which will be minus 1 plus or minus square root of b squared. 1 squared is 1 minus 4ac. 4 times a quarter times 1 is 1 over 2 times 1, which will be 1 minus 1 plus or minus 0 over 2 over 2, which will be minus a half. So which is a repeated root? So for repeated root, we know that now, therefore, the solution will be y1 is e raised power minus a half t, and y2 will be t e raised power negative a half t. So we have y solution, yc to mean the homogeneous solution is given by c1 y1 plus c2 y2, which will be c1 e raised power negative a half t plus c2 t e raised power negative a half t. So then now next is to get the particular solution. Now, particular solution is determined by the nature of the right-hand side. In this case, we have a constant. So when the f of t is a constant, then we assume particular solution also to be a constant. So we let this to be, say, A, be a particular solution. So then now, yp prime will be 0, yp double prime will be 0. So when you substitute this into the original equation, we have 0 plus 0, then plus a quarter yp of t, which will be a quarter A, is given by right-hand side is 5 over 4. We have 5 over 4. So on solving this one, we get A to be 5. So therefore, yp is 5. So when we have yp is 5, then yc C1 e raised power minus a half t plus C2 t e raised power minus 2 t. Then the general solution is y of t equals to C1 yc plus C2. Okay, just yc plus yp for the homogeneous solution plus the particular solution. So yc plus yt. So which will be C1 e raised power negative a half t plus C2 t e raised power negative a half t, then plus 5. So that will be the general solution, but we have been told that C at 0 is a half, and I at 0 is 7 over 2. So which means then we can get y at 0, which was C at 0 plus I at 0. For this is a relationship between y, c, and I. So we'll have a half plus 7 over 2, which is 4. So which means then I replacing those values in this, I'll have y at 0 equals to 4 equals to C1. So 0 times negative a half is 0, e power 0 is 1. So this other part will be 0, then plus 5. So which means C1 is 4 minus 5, which is minus 1. Then y prime at 0 is the same as 1 minus c at 0. Or if I differentiate now this function here, so this is the same as 1 minus a half, or the value of c at 0, which is a half. Then now when you differentiate the solution y that you have obtained, this part, then we get y prime is given by C1. Okay, so negative C1 over 2 e raised to minus a half t plus, these are the part I will use product rule. So where we can let C2t to be u, and then this other part to be v. So I have u prime v plus v prime u. So u prime is going to be just 1 times C2, which is C2, e raised to minus a half t. Then I differentiating the v function, I get negative a half e raised to minus a half t times the other one I have negative a half C2t e raised to negative a half t. But then the derivative of 5 is just 0. So that is our y prime. So which means y prime at 0, which is a half, is going to be, this part will get negative C1 over 2, plus this part will be C2. This will be 0 because we'll be multiplying 0 by these other terms. And we know from this line that C1 is negative 1. So which means negative of negative 1 over 2 plus C2 should give us a half. So a half plus C2 equals to a half. So which means C2 is 0. So therefore, the specific solution is y of t. So C1, we have the value as a half. So we'll have a half e raised to negative a half. Then plus C2 is 0, so we'll have 5. So that is what, so C2 is negative 1. Okay, so this would be negative 1, not a half. So this should be minus 1. Minus 1, which you can rearrange as 5 minus e raised to negative a half. There's a t here, t. Then the last bit was now to explain what happens when to both to all the functions I, C, and Y as t approaches infinity. So, but before we do that, from this solution, we see that C of t is given by 1 minus y prime of t, which is 1 minus e raised to power negative t over 2. And so the I function will be a half into 1 plus 3 y plus minus 4 second derivative of y, which on substitution, we have I of t will be a quarter into 1 plus 3, 5 minus e raised to power negative t over 2, minus 4 into minus e raised to power minus t over 2 over 4. So I should check that when you simplify this, I will be 4 minus e raised to power negative t over 2 over 2. So therefore now we have the C function is given by 1 minus a half e raised to power negative t over 2. I function is 4 minus a half e raised to power minus t over 2. And the y function is 5 minus e raised to power negative t over 2. So when you get the limit of these functions as t approaches infinity, limit of C of t as t approaches infinity is 1. Limit as t approaches infinity of I is 4. And when you get the limit as t approaches infinity of y, you get 5. So this complete solution for the given problem. So for more other problems, problems on the applications of differential equations to finance and economics, use the contacts given. Thank you.